let's take an example and try to understand how a decision tree is formed. Let's say this is the data set that we have, where I have the target variable. The target feature is play golf, and it is either yes or no. So it's a classification task. And the input features or the attributes are outlook, temperature, humidity, and windy. For example, let's say currently it is rainy and the temperature is cool, humidity is normal, and it is not windy. In that case, playing golf is allowed, which means you can play golf. But for example, the outlook is, let's say, rainy and temperature is hot, humidity is high, and it is windy right now. So playing golf is not suggested. No for playing golf. So this is the kind of data that we have, and I want to build a decision tree model on this data to learn the pattern between input and output, right? And use that pattern to predict the future. To predict, given an input of a certain data in the future, what can be the output with a certain accuracy. So let's say if I go for the random prediction, that is, let's say I go for mode, that is a random prediction. So let's see, first of all, let's see what is the class distribution over here. How many records I have that belong to yes, and how many records I have that belong to no. I have 1 2 3 4 5 6 7 8 and 9 records belong to class yes, and 5 records belong to class no. 1 2 3 4 5 5 records belong to class no. Okay, so overall I have 14 records, of which 5 belong to class yes, and 5 belong to class no, and 9 belong to class yes. So if I go, let us say I go based on mode, what is the mode of this particular class variable? The mode is yes, because that is the most frequent class. So if I predict based on mode, that is, I will predict every time to play golf, right? In that case, what is my accuracy? Accuracy will be only 19 out of 14 times I am correct, and 5 out of 14 times I am wrong, right? So it's definitely not a great accuracy, and this is definitely not a good model. Going with mode is not a good model. I need some predictions happening in case when golf should not be played, right? There should be some predictions happening when golf should not be played, right? So definitely this is the accuracy based on the current situation, that is, given the data set, given my data set, nine by 14 is the accuracy. Okay, now I will explain how will decision tree actually divide the data into subsets based on certain criteria, right? And then it will try to increase the accuracy for us. That is the entire objective of decision tree model, isn't it? Decision tree model will try to divide the data into subsets like this, subset 1, subset 2, and try to, in the pursuit of increasing the accuracy. Okay, so over here decision tree model, or anyone can divide the data based on outlook, right? That is, let's say it can be divided when it is rainy, and when it is rainy and overcast and sunny, right? I could divide my data based on outlook. I could also divide based on temperature, isn't it? Maybe I will divide my data like this, that is, I have the data and it will be divided based on temperature. All the records belong to high will be in one subset, all the records belong to normal temperature will be in another subset. So basically I have 4 options available for me: option 1, option 2, option 3, and option 4. So I can divide my data based on any of these options. I can divide my data based on this one, or this one, or this one, or this one, into various subsets. But which one to choose? Which one will the decision tree choose? That will be the one which gives the maximum reduction in uncertainty, or which gives the maximum accuracy, right? Or the maximum reduction in uncertainty. So that will be calculated using a formula. We actually have 2 formulas. The first one is called as entropy, right? Or you can also call it as information gain. Second formula is Gini index. So both are used to calculate the reduction in uncertainty. Essentially, these are measure of level of uncertainty present on a particular data set or a particular subset. Okay, so using this formula we will see which particular uh, criteria will be picked, which particular feature will be picked, outlook or temperature or humidity or windy. Right, so let's see this with example. So let me take this over here. Okay, so let me write the formula for entropy. The formula for entropy is Pi log Pi, okay, minus P log P summation I for 1 to C, where C represents the number of categories. Okay, this is the formula for entropy. I'll just put it over here, which is very important to remember. This is the formula for entropy, and we will use this formula and try to find the level of uncertainty at each situation. So let's say initially I have my data, which is, let me put this down. Okay, so for this data set, let's see what is my uncertainty in at initial level. So data is over here, and 9, 14, 9 and 5, total 14. So how to find the uncertainty is like this. So I have what is the probability of yes, it is 9 by 14, and probability of no is 5 by 14. So it will be minus 9 by 14 into log 9 by 14 to the base 2 minus 5 by 14 log 5 by 14 to the base 2. This is what is the entropy of the entire data set. When I look at the entire data set, I have 14 records. Of these, 9 belong to yes and 5 belong to no. That's exactly what I've written here. As per the entropy formula, it is P log P for all of the categories. How many categories I have? In this case, I have 2 categories, yes and no. All right, for the category yes, the probability is simply 9 by 14. So 9 by 14 into log 9 by 14 to the base 2, and then summation for the other category, which is 5 by 14 log to the base 2 5 by 14. So this value turns out to be 0.94. 0.94. So this is essentially nothing but the level of uncertainty. On the data set level, on the entire data level. All right, so which means uncertainty is very high. Uncertainty is 94% approximately, 94% as per this entropy formula. Uncertainty is very high. So obviously I need to divide my data into subsets such that the entropy reduces or the uncertainty reduces. Okay, so let us see what will happen if I divide my data on the basis of outlook feature. So I could divide my data on the basis of outlook feature, temperature feature, humidity and windy. All the 4 options I can try. So let's calculate the values when I divide my data based on Outlook. So if I divide my data based on Outlook, this is how the decision tree will look like. So I have the entire data here, and that is divided into 3 parts. The first, second and third subsets are these ones. These are the records belong to rainy. These are the records belong to overcast, and these are the records belong to sunny. And if you see here, in this particular subset, there are 4 records and all 4 belong to yes, which means accuracy is 100% here, uncertainty is 0 here, which means there is an advantage in dividing my data into subset like this. If I look at the subset, wherever it is overcast or wherever it is sunny, I'm seeing an increasing in accuracy, right? Okay, so let's find out what will be entropy in each of this subset. So I'll write it like this: entropy with respect to Outlook underscore sunny subset. Okay, so over here, how many records I have here? I have 5 records, and out of these 5 records, how many of them are yes and how many of them are no? So 3 yes and 2 no. So the probability of yes is 3 by 5 and probability of no is 2 by 5. So the entropy at this level will be minus 3 by 5 into log 3 by 5 to the base 2 minus 2 by 5 into log 2 by 5 to the base 2. This is what the entropy at this subset level it will be, which turns out to be approximately 0.971. Okay, which is a higher uncertainty compared to at this level, but let's still continue. We have to see, is this a good feature to divide the data, yes or no? So for that I have to keep continuing my process. So let me find the entropy of the data that belongs to Outlook underscore overcast subset. All right, so I have here 4 records and all the 4 records belong to yes, which means I have minus 4 by 4 into log 4 by 4 to the base 2, and 0 record belongs to class no. So 0 by 4 into log of 0 by 4 class 2. So this will be equal to minus log 1 minus 0, that is equal to exactly equal to 0. Log 1 is 0. Exactly equal to 0, which means the uncertainty, the level of uncertainty is 0 in this particular data set. And that is true because all the records belong to class yes, 100% accuracy. There is no uncertainty here in this data set. Whenever I predict that all belongs to the record belongs to class yes, where the record belongs to this subset, right? And similarly over here, for this subset which belongs to Outlook rainy, what is the entropy? So as per the formula, it will be, I have 2 yes out of 5. So minus 2 by 5 is the probability for class yes. So it will be done like this, and minus 3 by 5 for class no. So 3 by 5. So which will be approximately equal to same 0.971. So these are the entropies at each of the subset level, which means this is the entropy or the uncertainty level at each of the subset level. Now what is the overall entropy on the entire Outlook level? That is, see, if this is the accuracy at this point and at this point and this point, then what is my overall accuracy or what is my overall uncertainty? Let's find out. The overall entropy is nothing but simply entropy at the Outlook level will be nothing but the weighted average of all of the subsets, weighted average, which means totally there are 14 records. Out of these 14, 5 belong to Sunny. And for Sunny, the entropy is this. Okay, so 5 belong to Sunny. 5 out of 14 records belong to Sunny, and the Sunny subset has an entropy of this much. Plus 4 records belong to Overcast. So 4 by 14 into 0 is the entropy of that particular subset. And the remaining subset, the Rainy subset, has 5 records out of the 14 records. 5 divided by 14 into 0.971. That turns out to be approximately 0. That turns out to be approximately, let's say it is 0.6936. Okay, so this is what is I get for this one outlook. All right, 5 into 0.971 into 2 divided by 14 is this one, right? This is exactly what I get. Now let us look at the entropy again one more time. So the entropy at the data level, when I looked at the entropy on the entire data level, the entire data level, the entropy was this much, 0.94, right? But when I divided my data into 3 subsets like this based on outlook, first subset, second subset, and third subset, and then I had entropy at each level, and when I combined the overall, the weighted average entropy turns out to be 0.693, 0.936, sorry, 0.6936. 0.6936 is the entropy. So definitely the entropy has reduced, isn't it? The entropy has reduced. And what is the reduction in entropy? The reduction in entropy is, or the information gain. Let me write it like this: information gain from the data till the outlook level, dividing the data till the outlook level, right? After dividing, that will be equal to 0.94 minus 0.6936, which will be equal to 0.2464. This is what I got. Information gain is this. Information gain is this, which means I have gained some information, that is accuracy got increased, that is uncertainty got reduced. Or I can also write this as entropy reduction. All right, so information gain is nothing but entropy before minus entropy after. Okay, information gain is entropy before minus entropy after. So in our case, it will be simply entropy before dividing the data into subsets. Before dividing the data into subset, I was doing the classification by looking at the entire data. In the entire data, the mode was yes, right? So I had a probability of 9 by 14, that is accuracy, and based on that, the entropy is 0.94 before dividing the data. Here I'm not dividing the data. So after dividing the data, this is what I had: 3 subsets. In each subset, I look at the mode. That will be taken as a prediction, so probability of yes minus the probability of yes into log probability of yes minus probability of no into log probability of no. So entropy at each level will be found. All right, yeah, and the overall entropy, the weighted average entropy, also will be found. So that is the difference between that is the entropy reduction or information gain. Okay, but I could have divided my data on the basis of temperature also. I have divided my data on the basis of outlook. So I had 3 subsets: sunny, overcast, and rainy, right? But I could divide my data on the basis of temperature also, right? Humidity or windy also. And if I do that, I've just written the calculation over here for reference. Entropy before dividing, entropy of the entire data was 0.94, which we calculated. And entropy, if I divide my data based on temperature, right? Temperature has 3 categories, which are hot, mild, and cool. So 3 categories. So I am looking at my entropy of the temperature, hot subset, mild subset, and cool subset, right? Similarly, I will find the entropy at each level. So I have 4 records in that belong to hot. So I have a look at this. I have 2 records here and one third one, and 3 records here. So out of 3 records, 2 belong to no and 1 belong to yes, and this record belong to yes. So out of 4 records that belong to hot temperature, 2 play golf, 2 not play golf. That's why I have 2 by 4 yes, 2 by 4 no. So which means when the probability is equal, we have learned this, when the probability is equal, the uniform distribution, which means the uncertainty is the highest, isn't it? Anything can happen. The output can be anything. It can be yes also, no also. So which means with equal probability, 50% probability, which means the uncertainty is highest. That is why we got 1 as the level of uncertainty using the entropy formula at this particular subset. And this subset, this is the entropy, and this subset, this is the entropy. Now let me find the weighted average of all the entropies. To know the entropy, if I divide my data based on temperature, so which is this into 4 by 14, because there are 14 records and 4 records belong to hot, and again 6 by 14 into this plus 4 by 14 into this. So overall I end up getting this as the entropy, and the entropy reduction or information gain from the data before split, that is from the original data, and by dividing the data based on temperature, is this much. 0.94 is what I had before, and after dividing the data based on temperature, this is what I have. So this is the information gain. Similarly, for humidity, this is the information gain, and for wind, this is the information gain. Which means if I show you on the everything, all the information in one place like this, let's say over here like this, okay, so you can clearly see that if I divide my data based on outlook, I'm having subsets which are sunny, overcast, and rainy. If I divide my data based on temperature, the subset is hot, mild, and cold based subsets, and like this I have. And the information gain I get for the outlook is the highest, right? Because information gain here is 0.247, here it is 0.029 and 0.048 and 0.152. So this is the highest, which is giving me in highest information gain if I divide my data based on outlook, okay? Which means the class distribution is not in a way that the uncertainty is highest, when I divide it based on the outlook. So it is the decision tree will pick outlook as the feature to divide my data into subsets, but not temperature, but not humidity, but not windy, because outlook is giving me the highest reduction in uncertainty or highest reduction in entropy, right? Or highest information gain. All are the same thing, just the terminologies are different. But conceptually, it's only we are trying to reduce the uncertainty. Okay, so that is why, as you can see here, the first split of the data set will be based on outlook. And here I have all the records that belong to sunny. Here I have all the records that belong to overcast. Here I have all the records that belong to rainy. So now, what is the entropy at this level? Entropy at this level is 0.971. Is it a good entropy? Yes, and over here entropy is 0, and over it is again 0.971, right? So overall entropy at the overcast level is 0.6936, right? Weighted average. But at this individual level, I think I can still do better. So again, decision tree will again try to divide this data, which is a subset data actually, this data into again subsets. It will again try to divide this data into one more subset, maybe this time based on Again, what are the options I have here? I can divide the data based on temperature, isn't it? I can divide based on wind, or I can divide based on humidity, right? I cannot divide based on Outlook because already that is done, and here I have all the records that belong to Outlook Sunny already, right? So I have three options. Again, decision tree will try to divide the data into subsets, again in the pursuit of increasing the accuracy, or pursuit of reducing the uncertainty. When uncertainty is reduced, obviously accuracy increases, isn't it? Uncertainty is less, that's why accuracy is increasing. Both are inversely proportional. So in the pursuit of increasing the accuracy, again the data might be divided based on, let's say, humidity. Then I will have here all records that belong to high, and then all records that belong to normal. The same process will be repeated again, and the entropy reduction will be found for the data with respect to this data, and with respect to dividing the data based on humidity and temperature and windy. Whichever will give the highest reduction in uncertainty, that will be picked as the next split. That will be the next split over here. That will be the next split. Okay, so this is in short the example of how a decision tree will be formed. In the next video we will look at one more example. Thank you.